Alright people, welcome back. So in today's episode, we're dealing with problem 63 unique parts 2. Okay, so it's a medium problem. It's again, I think very similar to the problems we already dealt with in the past. So we are given an m times n integer array grid. So here, for example, this is a box, this is also a box, but I believe that not necessarily we're dealing with a grid that is a box. It can be also a rectangle. So m and n can be different. There is a robot initially located at the top left corner here. The robot tries to move to the bottom right corner. Okay, the robot can only move either down or right at any point in time. Okay, it's very similar to the problems we dealt with in the past. An obstacle and space are marked as 1 or 0 respectively. So the grid is 0 if it is empty, or it's 1 if there is an obstacle, and I suppose this red thing is the obstacle itself. A path that the robot takes cannot include any square that is in the obstacle. Return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay, so guys, believe me or not, but basically this is the copy of the problem we dealt with last time. The only main difference is that there is an obstacle, but the robot can again move only right or down. And the reason why we can't do the thing with the permutations is because, of course, some moves are not allowed. So this is the time where we have to use a dynamic programming approach. Now, m and n must be between 1 and 100. And here is what comes to my mind. As again, we were already mentioning last time, what we can do is to simply say, okay, so we have to return the number of possible unique paths. Okay, so of course, for example, take this cell, right? So this cell is basically the number of unique paths that bring to this cell is basically equal to the number of unique paths that bring to this, because of course the only way I can arrive at this cell, which is, let's say, this is basically the second cell to the right. This can only be reachable through this other cell. Okay, so my idea is that, okay, of course in this scenario basically there are only two paths because now there is an obstacle. But now, for example, forget about the obstacle for a second. Okay, how do you get to the unique paths that bring you to the central square? Of course, this is equal to the number of unique paths of the cell above and plus the number of unique paths of the cell to the left. If you sum them, then you get to the unique paths that bring you to this cell. And if you continue to do that until the last cell, which will be basically the total value will be equal to the sum of the value in the cell above and the one at the left, then you basically get to the solution. So I believe we have to use a dynamic programming approach. Now, of course, there is an obstacle. So how do we deal with that? I believe what we can do is to simply do a for loop for every value, let's say in the cell, and once we get to this obstacle, if it is if the value in the grid is equal to 1, we set it to 0. So we set the value of the obstacle, the amount of the unique paths that get to here are 0, so that, for example, if I am in this cell, I will get the number of unique paths that I can that can arrive to this cell are equal to this plus this, but this is 0 because of course no path can go through the obstacle. Okay, so let's try to see if this is reasonable. Okay, but now we have to see how to implement it in code. So we have a m times n grid, and the top left corner is grid 0, 0, and bottom right corner is grid m minus 1, n minus 1. Okay. So here is the thing. I believe that if we initialize all these squares, because these are necessarily, they have to be initialized because the squares at the top left, let's say, have the peculiarity of not being equal to a sum of cells. For example, the number of unique paths that bring you to this third cell in the first row, they're just equal to the number of unique paths at this cell. Basically, they're all equal to 1. Okay, so I want them to be initialized at 1, and once they are initialized at 1, I can do a for loop even by row and get to the end. Okay, so I can get to something like, now for a second, let's just assume that there is no obstacle in these cells, because otherwise we may get a few problems. But let's say, for example, that we want to do a for loop. So for, yes, first we have to define, yes, absolutely. So let's define n as the length of the grid. Actually, let me check if they want us to use n or m. No, they want to use m as the length of the grid. And then I want to use n as the length of the grid, let's say 0. Yes, let's go. Okay, now we have both n and m. And now I can do something like for I in range n, let's say actually range m, grid I. Okay, so I 0. Okay, so this grid will be equal to 1. And for j in range n, grid 0, j is equal to 1. Okay, now we have this initialized at 1. Okay, now it's easy because I can simply do for I in range, and now I have to go from 1 to m. I can do something like grid, no, then I have to do another for loop. So for j in range 1 n, I can do grid I j is equal to grid I minus 1 j plus to grid j minus 1 I. Okay, and this basically is what we have to do in case there are no obstacles. So now what I can return is to return grid n minus 1 j minus 1 m minus, sorry, the first one must be m, right? Yes, so grid m minus 1 n minus 1. Let me increase a bit the size. Okay, and now I can submit, I can run it, and I'm going to get an error. It's not called grid, damn, it's called obstacle grid. Obstacle grid, obstacle grid, obstacle grid, obstacle grid. I hope I don't miss any point. Actually, let me copy this. Okay, so now if I run, I get a result, but the result is incorrect because I'm not taking into account the obstacles. So what I coded at the moment is the number of paths that you get if you don't have an obstacle. Now the point is, I want to see if there is an obstacle. Okay, so what I want to add is if obstacle grid is equal to 1, then I want to set it to 0. Else I set it to whatever, to the real sum. This must be true even here. So for example, if obstacle grid 0j is equal to 1, then I set it to 0. Else I set it to 1. And same stuff here. So now I'm basically saying, okay, do that, but if this, like if the value is 1, then it's an obstacle, so set it to 0. Okay, so here I'm gonna get I0. Actually here it must be, okay, so here it's I0. Let's be correct with the indexes. So this is 0j, 0j, yes. Okay, now if I run, you should get it. Damn, we have a wrong answer. Okay, so here the output is 0, but the expected is 1. Well, here the output is, what's going on here? So here in the end, it's gonna be 1, 1. It should be correct. So let's check what's not going very well. The output is 0. Okay, so in this for loop, we're basically saying something like so basically I will be equal to 1 and j will be equal to 1. Now obstacle grid 1, 1 should not be equal to 1. So this is going to be, these indexes are incorrect, my guys. Now I have to write down, I'm so stupid. I minus 1, no. I, j minus 1. These indexes are incorrect. Okay, let me check if now it works. It works, guys. Okay, that's fantastic. That's very fantastic. Let's submit it. That's not working, unfortunately. Okay, why? Because the output is 0, but the expected is 1. So the point is this, okay, m as length 1, n as length 1. So fair. N and m is equal to 1. So for I in range m, so this is going to happen once. If this is equal to 1, which is not, it is set to 0. Else, it is set. So it's gonna be like this is set. And then during the second for loop, since this same value is equal to 1, okay, I see. That is why we have to start at 1. Easy. Like, because we are basically changing back the first, like the value that the first row and the first column share. But still we've got a problem. We solved a minor problem, but we still get a problem. The output is 1, but the expected is why? Because of course you can start, like, because the first point is an obstacle. Yes, it's an obstacle. But this it is also initialized at 1. I see. So basically, if obstacle grid I0 is equal to 1, then not only we have to set obstacle I0 to 0, but we have to set all the others to 0. So I have to do something like, okay, let me think. I basically have to say, like, if I encounter an obstacle, all the others at the right must be initialized at 0. So I have to do a very fast for loop. So for, let's say, k in range I and then m, obstacle grid I0 must be equal to 0. And then I break the for loop. And that I think I must do also here. But now I must use key in range I n. And the obstacle grid, I think, must be, sorry, this is going to be j, is going to be 0j equal to. Okay, let's see if it still works. Now we added also this logical implementation, but no, it doesn't work. Why? Why does it not work? Okay, so you should imagine this grid as basically just one row, and right, it's just one row, not one column. Yes, it's one row. Okay, so sorry, I want to see back the wrong solution. So the first value is a 1. So for, let's say what happens. So m is initialized at 1 and n is initialized at s2. Now for I in range m, if obstacle grid I0 is equal to 1, so basically now I is equal to 0, and this is the only I that I'm gonna get. If obstacle grid 0, 0 is equal to 1, which it is, for key in range I, so 0, m, so 0, 1, so just 1, obstacle grid I0 must be equal to 0. Okay, good, because like what we have to do at the second time. Oh, I see the problem. Since here we're starting from range 1n, so it doesn't work because we're skipping it. Okay. So basically the problem is since we are going by row and by column, I just started j from range 1n, so that like if this is 1 at the beginning, then it's set to 0 and then it's set back to 1, because then it is not equal to 1, so we set it to 1. To avoid this, I started at 1, but in this specific scenario, j doesn't see that 1, so it goes to 0 and is set it to 1, while it should be set to 0 because there is an obstacle. You know what? We can add something here. We can say that if obstacle grid 0, 0, because that's the point. If 0, 0 is equal to 0, to 1, sorry, then we return 0. Because of course there is no other possibility, because there is no path that brings us to that. So let's try to submit and see. Okay, we solved that problem, but we still have to solve this problem. The expected is 0, of course. Yes, it's definitely 0. Why do I get 1? So basically this is just a column. So 0, okay, 1. Once we get to 1, every other column of this must be set at 0. So let's see what's the problem here. For j in range 1n, if obstacle grid 0j, if obstacle grid I0 is equal to 1, actually since now we have this check 0, 0, we can start at 1, I believe. Yes, I think so. Because of course we don't need to check the obstacle grid 0, 0 because it's already checked. So for I in range 1m, if obstacle grid 1, 0 is equal to 0 and is equal to 1, and this is the case. Now for k in range im. Since m is a big number, for key in range 1m, so basically we're doing the same stuff. Obstacle grid I0 is set to 0, and we break the for loop. Actually, yes, we break the for loop. So we go away from here, and we go to this for loop for j in range 1n. But since j is 1, there is no for loop. And then we return m minus 1, n minus 1, which in this case will be this value. I don't understand what's the problem then. I don't understand what's not going on. Now I've got a different wrong answer. Okay, let's use this test case just to be on the same page. So this test case is 0. The output is 0, but the expected is 1. Why? If obstacle grid is 0, 0, then it's equal to 1. They return 0. Then we're skipping it. We're skipping it. That's the problem. That's the problem. Okay, so we cannot skip it. Start at 1 here. We must start at m. And so this issue is solved. Okay. Now let's submit it again and let's see what we've got. We got 0, 1, 0, 0, 0, 0. Let's see if there is an int or anything. Yeah, hint 1. Use dynamic programming since for each value you move to the right. Yes, so we did. Assume dp ij is the number of unique paths to reach ij. Yeah, okay. Set its value in dp0. Okay, man, I already did these two things. I am sorry to tell you that we're dealing with a much more specific problem. So let's add this to the test cases, okay? So this is basically a gigantic column. So what I believe is that if I have this gigantic column, so where I have m equal to lot, let's say that this is 20, doesn't matter, and n is equal to 1. Okay, now for I in range, okay, so if obstacle 0, 0 is equal to 1, we return 0. This is not true. Now for I in range m, this is the main point. For I in range m, if obstacle grid, so for I in range 0, 20, if obstacle grid, let's say 0, 0 is equal to 1, it doesn't happen, but 1, 0 is equal to 1. For k in range 1, 20, obstacle grid, we set everything to 0. We set everything. Then we break the for loop. I see. Okay, now I see. Now, of course, we set everything to 0. But yes, we start here. So for example, if obstacle grid, like here, for example, we have for I in range 1m, but then for j in range 1n, since there is no j, like there is 0 repetition, like 0 in range I 1, 1, so it's gonna be nothing. So there is no repetition. So we skip these two for loops. We skip this. We skip this. I really don't understand. We skip this. We skip this, which must return m minus 1, n minus 1, which must be 0. Why it's 1? That's crazy. I don't understand. I don't understand, guys. Okay. Yes, I think... guys, I think there must be an like a bug somewhere, like an index. ij, n minus 1, n minus 1, which is exactly what I for key in range. Okay, yes, let's go, guys. Okay, stupid. Okay, so here the problem was I was using I, so I don't even know what problems I was causing because of that, because there is key here. Let's submit, and again wrong. No way, I don't like this. Okay, so here we have a big output and a very big output here, but they do not coincide. Damn. Okay, but maybe we have the same problem here, which is actually the case. So maybe if I now submit again. Woo! Guys, let's go. Well done, guys. Okay, so it was just a problem with syntax, but the algorithm was there. So well done, people. I'm really happy. Like, I'm really satisfied by this problem. So well done, people. Okay, now let's see if we can actually optimize this code. So we have the okay, memory complexity. This is 01 because we are just returning the input, so we're adding 0 extra memory. Now time, I have a for loop here, so this is on, but this is om times n, so this is the bottleneck. So this is on times n. Okay, guys, I really believe there is a potential for making this on instead of on squared. But I'm quite sure that to do that, to increase the memory complexity, at least to on, something like. So it's more or less like a trade-off. So since there is like the best solution, like there is not a best solution, it really depends on the requirement. I think we were good with this solution that we found. So guys, thank you very much for watching this video and see you in the next episode.